Hi, this is Mohammad Musharraf from ISC department. Today we are going to discuss about solar space cooling system. So let's start with introduction. The state of the art of solar cooling has concentrated primarily on the development stages of system in the last few years. Various methods have been researched and some demonstrated, but only a few systems has been installed for other than research purpose. Solar cooling systems are attractive because cooling is most needed when solar energy is most available. If solar cooling can be combined with solar heating, the solar system can be more fully utilized and the economy benefits should increase. Solar cooling systems by themselves, however, are usually not economically at present fuel cost. Combining solar heating and cooling system is not easy because of the different system requirements. Absorption cooling. Absorption cooling is the most commonly used method of solar cooling. An absorption refrigeration machine is basically a vapor compression machine that accompanies cooling by expansion of a liquid refrigerant under reduced pressure and temperature, similar in principle to an ordinary electrically operated vapor compression air conditioner. An absorption refrigeration machine is basically a vapor compression machine that accompanies cooling by expansion of a liquid refrigerant under reduced pressure and temperature, similar in principle to an ordinary electrically operated vapor compression air conditioner. Figure 1 shows a typical lithium bromide absorption cooler. In the absorption cooler, heat is supplied to the generator in which refrigerant is driven from a strong solution. Rankine cycle heat engine cooling. Rankine cycle systems are still in development with only a few in absorption. In this system, extra power produced by a heat engine driven the compressor in a conventional vapor compression type cooling machine. The thermal energy input to the heat engine can be from a solar collector or from a solar collector and a fossil fuel compressor. The fossil fuel can complement solar energy or it can be used alone as the auxiliary engine supply when no solar energy is available. Alternatively, electrically can be used as auxiliary energy supply, cooling and electric motor directly to the compressor shaft. Another option is a motor generator using a heat engine for generator electricity. Solar energy is available and there is little or no cooling load. From state of the art consideration, two types of fluid heat engines are primarily feasible in solar cooling units. In one type of engines, the working fluid cyclically changes phases from a liquid to gas and back to liquid. Essential cooling, the Rankine engine, vapor compression, and the absorption cooling unit operate on the basis of closed cycles. Fixed amount of working fluid are circulated within sealed equipment. The working fluid do not come in contact with the building air. Design cooling system, on the other hand, may be designed for open cycle operation since the only circulation fluid involves air and water. The basic concept is to Dehumidified air with recent evaporative cool and dehumidified air and regenerate the descent with solar derived thermal energy. In the schematic diagram of a solar descent cooling thermal collector with thermal collector heat heater auxiliary heat exchanger. This shows the descent cooling of a solar cooling system. Other cooling methods. Other methods using solar heating equipment but not direct solar energy should also be considered. This method shields the thermal storage unit of the system during the night and use the chilled medium to provide the daily cooling load. Method of chilling the storage include radiation of the heat to the night sky and heat exchange with the night air cooled or uncooled vacuum means. The chilled storage is usually directly via heat exchange with the building air. Both liquid and water storage are suitable since the only additional hardware requirement is that a route the fluid. A heat pump can be used during the day to cool the building and reject heat in the thermal storage unit. System controls. System controls are used to turn on a circulating pump or a boiler to the collector only when the sun is providing heat. Differentiated thermostat and the commercially available to turn on the collector pump only when the collector plate temperature is the present number, usually 20 degrees hotter than the storage tank bottom temperature. Differentially thermostats are available with the high temperature protection and the low temperature free protection. High temperature protective is important, especially related to collector in that it prevents a very hot collector from suddenly receiving a supply of a cold water or providing a thermal shock and damage the collector components. Piping pumps values pipes and heater sizing. Piping should be designed for a low pressure drop. All exposed piping should be well insulated with provide weather restriction insulation. Electric union should be used to connection between the similar materials, rubbers and the silicone house used for a connection must be of high temperature type. The pipe end should have refers to provide a good seal with the in low pressure systems. Spring type pumps are preferred because they compare the thermal expansion. Copper pipe is preferred to steel due to its longer life expectancy and relative ease of installation. The thermal expansion should be provided for all piping or hot tubing. Pipe size should be according with the recommendation method, but on most installation the following essential are reasonable.